So let's now look at a more complicated scenario. So what we have seen till now is there was a switch 0. It had 4 PCs connected to it. PC1 and PC2, it was in VLAN 1, the native VLAN. You could have configured it in some other random VLAN as well. PC3 and PC4 was put in VLAN 2. Now what happened is, imagine this was an office, this was a small company. Initially they had only 4 people, only one, let's say, floor in an office. Then they became rich, they expanded, and they moved into another floor. So they now have 2 floors. And this guy and this guy stayed in the top floor. These 2 guys went below the second floor. But PC1 and PC2, let's say, belongs to the same department. So they are in, let's say, VLAN 1 or whatever VLAN you want to put them into. But PC4 and PC3 are in VLAN 2. But obviously, we now need 2 switches. We are quite far from each other. Let's imagine these 2, let's say, floors are quite far. There is no wire through which you can connect, or this switch was new members joined, and all the ports of the switch were what is called taken by all the other people. And these 2 guys will move to the second floor. So what I have done now, exactly like this. See, if you put your cursor here, we have only 2 links up. Fast Ethernet 1 and Fast Ethernet 3. That's for this simulation. One is in VLAN 2 and one is in VLAN 1. Exactly same thing I did here. I put 2 links, connected 2 links to these 2 PCs, and one I put in VLAN 1 and other than put in VLAN 2. This link I have configured as VLAN 1. This link I have configured as VLAN 2. But now obviously we need to connect them. There has to be a connection so that they can, this PC should be able to contact this PC at least, because they belong to the same department. Now, if you remember these links, these ports, we configured them as access ports because they are directly connected to the PCs. But when you connect 2 switches, we need to configure them as what is called trunk links, trunk ports. Just remember analogy to, let's say, or PS, public switch telephone network, where we have a local loop or local link from your landline telephone to your nearest office, telephone office, and then big wires, big trunks. Just a name just indicate is a big bandwidth thing, which will take multiple users' data and voice traffic to different places where they need to go. So it's the same analogy. So these are traditionally will be low bandwidth links, but these switches will communicate at very high bandwidth because they carry traffic of multiple users at the same time. But the more important thing is these 2 generally, when there was a single switch and all 4 were connected to the single switch, the switch could determine, it could prevent a PC in one VLAN from connecting to a PC in another VLAN. But here, what these 2 will have to do, this link, it will have to allow traffic from both the VLANs. In this link, in this access VLAN, only traffic of VLAN 1 will flow. In this access VLAN, only traffic of VLAN 1 will flow. Similarly, traffic 2. But if these 2 switches are linked, if this guy wants to connect to this guy, this link should allow, or this port and this port, there is a port, there should be 2 ports configured, which should allow VLAN traffic of VLAN number 2 and VLAN traffic of VLAN number 1 as well. So it carries traffic of multiple VLANs, not just one. So this type of links and this type of ports are called trunk ports. So we will configure a trunk port, two trunk ports here now, so that we allow them to communicate and see what happens. So what we'll do now, we have this link connected. Fine. What's the link? Let's see. There is another link that has come up. It is, I think this is 1 by 1. So if I pull this entire thing down, yes, so this is 1 by 1. So I have to configure this interface as trunk interface, and this interface also as trunk interface. Let's do that. We have this uh, again poster for our help. You can obviously go to Google and again find this information. So we will first go to switch 1 and switch 0. Let's do this. Okay, so let's move this a little bit here, a little bit here. Okay, switch enable. So let's first configure terminal. In this mode, we have to enter now the terminal in our interface FA1/1 fast Ethernet 1 by 1. Now these are very simple switches. In these two switches there is no gigabit Ethernet available ports that enable gigabit Ethernet, but there are other switches which will enable gigabit Ethernet, so it's a high bandwidth link. But for this mock case, let's do this, whatever is available in these two switches. So now again, similar type of command, switch port mode trunk. Now there is another command you can see here, encapsulation.iq. This is 802.1q, which we need for communicating what is called traffic, which VLAN traffic. Now we'll see how that goes, but at the moment you see this command is no longer required. And let's bring this. There are many ways, there are many protocols which allow VLAN, or used to be. One of this is ISL. This is a Cisco proprietary protocol, but this is generally no longer, not many, apart from Cisco, some old routers, nobody uses it. Switches, old switches. Even Cisco probably doesn't use it now. This is the IEEE standard. We have seen the IEEE 802.1q header, the link layer, data link layer, where this part, it contains the VLAN ID, and there are a few different fields. It is a slightly different from the Ethernet, classical Ethernet header, what is called frame. It has basically the most critical difference is the inclusion of a VLAN ID. It's a 12-bit ID, so you can have 12 to the power 12 means 4096. 4096 are allowed, but obviously one or two are not kept reserved for other purposes. But 496 VLANs are allowed basically by the 802.1q protocol. So this command is no longer used. If in fact, if you want to, let's see, I think it will show error. In fact, I found out it gives an error, but for your encapsulation 1q, see, it gives an error. There is no point. Now there are some other commands here you can use, but let's not go for all that at the moment. Okay, so we have configured this. One thing you can do, obviously, there is another command I should be able to show interface FA 1 by 1 switch port. Hope it works. It does not work here. So let's exit this and let's try here again. It will not here. Oh, no, it's not a. So interface FA 1 by 1 switch port. Let's see what it gives. See this command in the root mode outside the configuration. We have to get outside. You see, it shows the switch port is enabled F1 by 1. This is the port or the interface trunk, and automatically only .iq is enabled. And what has it given? It's a trunk now. It's a trunk port. It's not an access port anymore. And what it is saying is trunking VLANs enabled all. That means all VLAN traffic it will allow through this interface, this port. Now let's do the same thing. Let's do the same thing for switch 4. So here we have switch enable configure terminal. Now we'll do what is the FA 2 by 1 interface FA 2 by 1. We have to give switch port move trunk, and that's it. We don't have to do anything else. If I do exit, if I do show interface FA 2 by 1 switch port, you see it's a trunk .iq is enabled, and all VLAN traffic it will allow to pass. So we have now configured it. Don't need to do anything drastic anymore. That's fine. But let's now see whether these two are in the same VLAN, whether they are able to ping each other. So we'll put simulation mode. This go to command prompt. We'll do ping 10.1.1.2, and let's give it only one time. Great, ICMP. No ARP is needed anymore. These people have already learned. We have pinged them many times. They have their ARP table floated or completed, or what is called filled up. Yes, it allows. And it goes there. No issue at all. Then what happens? I think PC2 probably doesn't know. Let's see why it is ARP. Maybe we have not pinged PC1 to PC2. I don't know why that's a thing, but it does not matter. You can again, this is ARP. It goes to the target destination in VLAN 1, no issue at all. At ICMP reply. Now there is some other things that will go on. We'll not bother about them. He said simulation. So this was successful. So PC1 can ping PC2, as you can see. Can it ping PC3? It should not be able to. So let's do the simulation. ping 10.1.1. 10.1.1.3. What happened is when it knows the ARP of this PC, since it has pinged all the PCs at least once, I guess, so it knows the MAC address and all that. But when it sends the packet, so through this interface, the packet is sent. Then you see, it does not allow. The switch will not allow a packet to be delivered to this PC3, just as before. I think in this case, PC1 did not know the if I see PC1's ARP guess, yeah, it did not know PC3. So the ARP request was, that's why request and reply was started. But in any case, it will not allow any traffic to reach PC3. However, it will allow traffic to reach from PC1 to PC2. Let's now look once again. There is a very important concept here before I forget. Reset the simulation. So ICMP packet generated reaches here. Let's see what the packet looks like. We know in VLANs, we have always an Ethernet, what is called an 8.802.1q packet. But if you see here, it's an Ethernet packet. It reaches the switch as an Ethernet packet. It goes as an Ethernet packet. Let's move on. If I analyze here, again, Ethernet. It's an Ethernet frame, mind you. Sometimes I misspeak packet and frame, but I hope you understand what I'm trying to say. Why is this? And let's continue again. Ethernet, no issue at all. And we'll stop this simulation. What you must notice that each of these computers, when they send data, they will never use 8.2.1q Ethernet frame on their access link. In these access links, never will 8.2.1q will be sent. Only in this, in between the trunk interfaces, or this trunk link, will 8.2.1q be sent. We'll show you. And the other thing is, when you are in the native VLAN or VLAN 1, that VLAN will never have any VLAN tag. That VLAN will never carry 8.2.1q. So even here in this trunk, we saw an Ethernet frame being carried, classic Ethernet frame 802.3, not 802.1q. But if we now try to send from this to this or this to this, we'll see something different. We'll restart the simulation, reset the simulation, we'll stop this. We don't need this anymore. Let's try to ping from here. 4. So from 3 to 4, and let's see what happens now. So this is the first time they are pinging, but let's go ahead. It's reached there. Then what? Let's see. Now you see, it is an ARP packet, but when it reached the switch, it was an Ethernet packet. But then in this link, it has converted it, when it is forwarding in this link, it has converted it into an 8.2.1Q packet. So now let's go forward. Let's see here what happens. Now it got an 8.2.1Q. It knows that this packet is coming from a particular VLAN, VLAN number 2. So it can only send it to somewhere in VLAN number 2. But when it sends it on an access link, it has to send it on an access link. The switch converts that into an Ethernet packet. It removes that VLAN information. So this packet, as will go out from switch 0, will become an Ethernet packet, one Ethernet frame once again. So it goes, yes, and this the process continues. Then finally, when they learn the ARP process is complete, then ICMP will start ICMP reply and so on and so forth. So you can create few more scenarios like this and investigate on your own what are the things going on. I will stop here. I will allow you to investigate on your own with different networks. You create your own fancy networks and try configuring access different VLANs, different access links, access ports or access links, and different what do you call trunk ports or trunk links. Now things become more and more complicated. In reality, we have just taken only one step. These switches will be finally connected to routers, and these routers will be connected to other routers, and finally to the internet. It's a complete mesh of different devices, and we have to configure all of them correctly. So let's stop here.